Welcome to Chemistry with Caroline. In this video, we're going to look at reactions at the benzylic position. And so in all of these examples, there's going to be a benzene ring, and then that next door neighbor spot, right, is the benzylic position. It's pretty reactive because of that pi system next door. But what we'll see in all of these examples, which are all reactions that you've seen previously, is that the benzene ring is going to remain intact. We will not disrupt the aromaticity of the benzene ring. Whatever reaction is taking place will take place right next door to that, but the benzene ring won't be disturbed itself. So as this first example, I have two allylic halogenation reactions. We use NBS typically to give a brominated product, and then we can just use Cl2 to give a chlorinated product. Both of these reactions are going to go through this intermediate here, where we create a radical at the benzylic position, and then that radical can be pushed around through the pi system of the benzene ring. So all of those radical intermediates help to stabilize that intermediate system, but you won't ever see the substitution of a bromine at any of the radicals that are inside of the benzene ring, which are three of the contributors, because that would disrupt the aromaticity of the system. And the takeaway of this video is just going to be that the benzene ring remains intact, and it's the next door neighbor position that reacts. In this starting material, the functional group at the benzylic position is an alkene. So the benzene is full of pi bonds, and this alkene has a pi bond as its functional group here. But we'll see that the pi bonds in the benzene ring won't react under these conditions that an isolated double bond would, because they are aromatic. So again, that benzene ring is going to remain undisturbed. Only the exterior alkene is going to react. So when we did reactions of alkenes, we saw that the addition of HBr gives a Markovnikov addition of the bromine. That will do the same thing, but only to that exterior alkene. If we used peroxides in the presence of HBr, we could get an anti-Markovnikov addition to the alkene. So the bromine goes to the less substituted carbon, okay? That's still going to happen, but again, only to the exterior alkene. We can see the Markovnikov addition of an alcohol if we used H2SO4 and water. And we could see the anti-Markovnikov addition of an alcohol using hydroboration oxidation. So in all of these examples, the reagents that I am given react with an alkene, but they don't react with the pi bonds that are inside the benzene ring. The benzene ring remains intact. So these are some specific examples of the types of electrophilic addition across alkenes that we've learned previously, but they hold true for all of these types of reactions. Alkenes in a conjugated cyclic aromatic system like a benzene are not going to react under the same conditions that alkenes that are outside of that set of conditions will. So this has been a look at the difference in reactivity between a benzene derivative or some other aromatic derivative and an alkene or the benzylic position just exterior to that ring. If you found this video helpful, please like, subscribe, and share with your friends.